This is 4.3 part 3. If you have not watched the previous two parts, please go back and do so because I go over how to change a non-base 10 number into a Hindu Arabic or base 10 numeral. So this is just continuing on what we were looking at before. In this particular problem that we stopped off in the last video, it asks us to write 94 BA2 base 16 as a Hindu Arabic numeral. So just as a reminder, I'm going to put on here that I'm in base 16. Remember, that's hexadecimal. And also remember that any value over 9, such as 10, 11, 12, and so on and so forth, we have to represent those as letters. So the first thing I'm going to do is I am going to break this up. So 9 times 16 to the plus 4 times 16 to the plus. Now instead of writing B, I know B equals 11. So I'm going to put 11 times 16 to the plus. Now I'm on the A, which is 10. 10 times 16 to the plus 2 times 16 to the. And again, we're working backwards. So the 2 is in the 1's position, so that became 16 to the 0. The 10 was in the 16 to the 1st position. The 11 was in 16 to the 2nd position. The 3rd is 16 to the 3rd. And the 9 is in the 16 to the 4th position. So this is what it looks like at this point. Now we got to figure out these numbers. So 9 times. I downloaded an app. It is TI-84. The only thing is it does cost money, so I'm just letting you know. But I want to know what 16 to the 4th is. And when I type that in the calculator app, I get 65,536. So 65,536 plus 4 times. Now I need to know what 16 to the 3rd is. So again, I'm going back to that calculator. So 16 raised to the 3rd power is 4096. 4096 plus 11 times 16 squared, I believe is 196, but let's see. I could be wrong. And I'm glad I checked it because I was. It's 256. Plus 10 times 16 plus 2 times 16 to the 0 is 1. Okay, now at this point, we got to simplify this again. So I'm going to take 9 times 65,536. So let's go back to the app. I might be able to sneak up here. Yeah, they're not going to let me do that. Okay, so let's clear this out. So 16 to the 4th times, 16 raised to the 4th times, I'm not sure why it's doing that. Okay, well anyways, 65,536 times, and that first value, I have to go back and check it again. It's 9, so 9 times that. And that equals 589,824. 589,824. 589,824. Okay, next number, 4 times 4096. And that's 16,384, so 16384. Plus 11 times 256. That equals 2816. plus 160 plus 2. Okay, so now my next step is going to be to add all of these numbers up. Okay, so let's see what we can do here. Okay, so the first number is 589. So 589, 824 plus 16,384 plus 2816 plus, whoops, we got to clear that out. I forgot the 1. Okay, now that's better. And 160 plus 2. And when I do that, I get 609, 186. So 609, 186. Okay, and that would be my answer for 94 BA to base 16. Okay, let's go ahead and check the next one. Write A 96 7B12 as a Hindu-Arabic numeral. The base is 12, which is Dosnal, if you remember that from the last videos. A is 10, B is 11. So that's just a reminder. So again, I'm going to break this up. 10 times 12 to the plus 9 times 12 to the plus 6 times 12 to the plus 7 times 12 to the plus 11 times 12 to the. Okay, again, I'm working backwards. This is going to be 12 to the 0, 12 to the first, 12 to the second, 12 to the third, 12 to the fourth. Okay, so we got to figure out what 12 to the fourth is. So 12 raised to the fourth power is 20,736. So 20,000. And I'm going to go check that. Okay, looks good. So this first one's going to be 10 times 20,746. So when we multiply by 10, we're going to add a 0. So 207,460 would be the result of that. Plus, let's do 9 times 10, or 9 times 12 to the third. So 12 raised to the third power will give me 1728. So I'm going to put 1728 there. Plus 6 times 144 plus 7 times 12 plus 11 times 1. Okay, so let's figure the rest of this out. I'm going to take 9 times 1728. I get 15,552. Okay. Plus, I need to figure out what 6 times 144 is. $864 plus 7 times 12, 84 plus 11. Okay, so I'm going to add all those numbers together and see what I get. So 20,700 or 207. I have that decimal, or let me fix that. There we go. Okay, so 207,460 plus 15,552. 2 plus 864 plus 64. And I get 223960. 223960. We still have to add, though, the last two values. The last two values were 84 and 11. So I need to do that as well. So I'm going to add those to that. Oh, actually 84 was in there, so we just have to add 11. 223971. So 223971. And that's my answer. Okay, so again, all those values that we added up, I just forgot to add 11 to that. And that gives us a final answer here. Okay, so there you go. That's how we do changing any base to Hindu-Arabic. Now we're going to go backwards. So this is the next objective. We're going to convert from Hindu-Arabic base 10 to a system other than base 10. So if you're going to another base system, you are going to be dividing. Very, very, very important, okay? When we go backwards, it's harder. Okay, so if you're going to our system, multiply. Their system, divide. Okay? So you will need to perform long division. So if a lot of you are saying, well, I'm not really good at that, that's okay, because I'm going to show you a shortcut on the calculator. And what we're going to do is we're going to find the closest positional value that is not over to the value of the number in question. This will require you to write out each of the base's powers, starting with the base raised to the 0 power. Then, you're going to divide your original number by the base's power that is closest to the original number, but doesn't exceed it. And I'm going to show you how to do that on your calculator. The next thing you're going to do is find the remainder. The remainder is going to be the value that you're going to divide by, and you have to drop the next positional value down. If that number doesn't work, you know, maybe it's smaller than what you're dividing by, then you have to use a place value of 0, and you'll see an example of that. And then you have to repeat the steps until you get down to whatever base value you are looking at raised to the 0 power. Okay, so again, when we're going to our system to theirs, we have to divide. Okay, so it's harder. So let's check this out. Write out all powers of base 5 until you get a number closest to 452. The question reads, convert 452 to base 5. So I have 5 to the 0, I know that's 1. 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is 125. 5 to the fourth is 625. Now I need the number that comes closest to 425 but does not exceed it. So that means I need to start at 5 to the third. Okay? So we're going to divide 452 by 125. Now this step is important. Let yourself know that you started with 5 to the third power. Just hang that out on the side. Okay? Now here's the trick that I was talking about. Let me go down to the next page. When we take 452 and we divide it by 125, so let's fix the notes. It should say 452 divided by 125. Let's see what happens. So let's fix this up. 452 divided by 125. I get 3.616. So let's go back here. 3.616. Okay? So what you're going to do is you're going to ignore the 0.616 and we're just going to use 3. Okay? You cannot put decimals. Alright, so what we're going to do is now we're going to perform long division. So I'm going to take and multiply the 3 by the 125. Okay? All right, so 3 times 125, and I know what this is, but I'm just showing you. 3 times 125, and that equals 375. Okay, so 375. So now I'm going to subtract 375 from the 452. Okay, so that step is shown right here. So let's do that. I get 5, 4, 3. So this becomes 7 here and a 7 here. So our remainder is 77, and that's what I'm interested in. So there's two pieces that I'm interested in. I'm interested in the 3, which I'll put pink around that, and now I'm interested in the remainder. Okay? So what I'm going to do now is I'm going to take that remainder of 77. By the way, we need to fix our notes here. So we're going to do 77. And we're going to do the same process, but we're going to fall down and then to the next base. So the next base is 5 squared, which is 25, okay? So I'm going to take 77 and divide it by 25. Okay, so you're going to see that step here. So 77 divided by 25. So 25 times 3 is 75. Okay, and that's right here. And when I subtract this, I get 2. All right. So again, I am interested in this number up here, this 3, and I'm interested in the remainder. The 3 I'm going to keep, and the 2 is the next value down. Okay, so we take the remainder of 2 and we divide it by the next base down, which is 5 to the first. Okay, 5 divided by 2 doesn't work. You're going to get a fraction. Okay, so 5's too big. It's bigger than 2. So when that happens, you have to place a 0 in it, and you just drop down to the next positional base. So 5 to the 0 is 1. So now I'm going to take 1 divided by 2, which is 2. So 1 goes into 2 times. So let's fix the notes right there. So again, I'm interested in this 2 here and the 0 from above. And we don't have a remainder. Remainder is 0, and that's how I know I'm done. Once you reach your base to the 0 power, you're finished. So what's the answer? The answer is 302, and then I need base 5. So I have to have that subscript in my answer, okay? So again, I'm interested in what number goes into that, and I'm also interested in the remainder. So let's try another one. I'm just going to do this on that. Oh, I did miss an extra 3. Sorry about that. So this should be 3302. We need to fix this. 3302 is equivalent to 452. Okay, so let's look at the next one. Convert 5,329 to base 12. Okay, so step number 1 is I'm going to write out all the bases of base 12. So 12 to the 0 is 1. 12 to the first is 12. 12 to the second is 144. 12 to the third is, I don't know. So let's check it out. That's 1726. So 1720. I think it said 8 actually. 1728. Yeah. Okay. All right. Whoops. Sorry guys. I'm all over the place. There we go. So I'd keep on going because we're close to 5,329, but let's see what happens when we have 12 to the 4th power. Okay, so 12 to the 4th. So 12 raised to the 4th power is 20,736. So 2736. Okay, so 12 to the 4th is too big. So the closest position we can start with is going to be 12 to the third. So this is where we're going to start. So I'm going to take 5,329 and I'm going to divide it by 1,000. Whoops. Divide that by 1,728. Okay, so on the calculator, I'm going to take these two numbers and divide them. So just to help me out, I'm just going to write this out on a piece of paper because these numbers are big. Okay, so 5,329 divided by 1,728. And when I do that, I get 3.08. Okay, so again, we're going to ignore the 0.08 and use the 3. Okay, so this is my first number I'm going to use. Okay, so what I'm going to do is now take 3 times 1728. And that equals 5,184. Okay. And then I'm going to subtract these. So I'm going to subtract these two numbers, 5,329 minus 5,184. And when I do that, I get 145. Okay, so 145. This is my remainder. So I'm going to take the remainder and I'm going to divide it by the next positional value down. So remember we started with 12 to the third, we're now on 12 to the second. So 12 to the second is 144, and this is easy because we just can take 144 into 145 one time, and when I do the subtraction I get a remainder of 1. Okay, so I have to go down to the next positional system, which is 12 to the first. So 12 going into 1 doesn't work. Okay, so it doesn't work. When that happens, we need to put a 0 placeholder. Okay, so far I have 310, but I have to continue on. So I drop down to 12 to the zeros position system. Okay, so I still have that remainder of 1. So 1 and 12 to the 0 is 1. So 1 goes into 1 one time with no remainder. Okay, once you get down to the ones position, you're done. After that, so 3101 base 12 is my answer. All right, let's do another one. Convert 10,375 to base 16. So again, we start with writing out all the positions. So 16 to the 0 is 1. 16 to the first is 16. 16 squared is 256, I think. Yes. Okay. 16 to the third. Let's see what that looks like. That's 4096. And then 16 to the fourth, which is probably going to be too big, but let's check it anyways. 65,536. 65,536. Okay, so that's too big. So I'm going to start with 16 to the third. So I'm going to take 10,375 and divide it by 16 to the third, which is 4096. Okay, so I'm writing these values down because it's hard to go back and forth to the calculator. Okay, so let me go do that. 10,375 divided by 4096. And when I do that, I get 2.53. Okay, 2.53. Okay, so let's go ahead and write that 2 down. That goes into it twice. Okay, so that's my first digit is a 2. So circle it. So now I'm going to take 4096 and multiply that by 2 because I'm trying to do the long division. So 4096 times 2 equals 8,192. So 8192. Okay, so now I'm going to take 10,375 subtract 8192. And when I do that, I get 2,183. So 2183. So 2183. Now we're going to divide that by the next positional value down. So this is my remainder. Okay, so my remainder, I put the divisions bar over that, and now I'm on 16 squared. So 16 squared is the next positional value down, and that's 256. Okay, so now I'm going to take 2183 and divide it by 256. So let me do that. And that equals 8.5 and some change. So I'm interested in the 8. So I'm going to take 256 times 8. And when I do that, I get 2048. So let me write that all out here. Again, the magic value was 8, and 8 times 256 gave me 2048. And now I have to subtract 2183 by 2048. So 2183 minus 2048, and when I do that, I get 135. Okay, so that's my remainder. That's going to go under the division sign, and we're going to drop down to 12 to the first power. Okay, so let's write that all out. Okay. So I'm going to take the remainder of 135, and I'm going to drop down to the next positional system down, which is 16 to the first. So 16 goes into 135. Let's check that out. Oops. So 135 divided by 16 will give me 8.43, so on and so forth. So I'm interested in the 8. So I'm going to take 8 times 16, which will give me 128. So that's what I need to subtract. So let me go put all that information in. So again, this was 8. 8 times 16 gave me 128. Going to subtract those two. So this became 7. Okay, so now I'm working on 16 to the 0. 16 to 0 is 1. So I'm going to take the remainder, put it under the division sign, and 1 goes into 7 times evenly, no remainder. Okay, so the answer is going to be 2887 base 16. Okay? All right. I think, do we have this? This is the last one. Let's just get through it. Convert 5,326 to base 7. So again, let's start with 7 to the 0, which is 1, 7 to the first, which is 7, 7 squared, which is 49. Now I need 7 cubed. So 7 cubed is 343. So 343. And then we need 7 to the 4th. So 7 to the 4th. 2,401. Okay, let's do 7 to the 5th just for giggles. 7 to the 5th. That's 16,807. So 16,807. That's too big. So we have to start off with 7 to the 4th. So we're going to start there. Okay, so we take 5,326 and we're going to divide that by base 4, or 7 to the 4th, I should say, not base 4, base 7. 7 to the 4th, which is 2401. So I'm going to put a little note, this is 7 to the 4th. Okay, so I'm going to, again, guys, I'm writing this down on a piece of paper because it's just allowing me to keep on flipping back and forth. So 2401 divided by 5326. Okay, so 5326. 5326 divided by 2401. And when I do that, I get 2.2 and some change. So I'm going to use the 2 there. And now I'm going to take 2401 times 2. And that's 4802. Now I'm going to write down what I just did. So what I just did was I found out that 2401 goes into that value twice. So I'm going to highlight that because we're going to use that later. And 2 times 2401 is 4802. I'm going to have to subtract these values off. So I'm going to do that. 5326 minus 4802. And when I do that, I get 524. So 524. So 524 is going to go down to the next base system down. So since we started out with 7 to the 4th, I have to dip down to 7 to the 3rd. So 524 is going to get divided by 7 to the 3rd, which is 343. Now 343 goes into 524 once. So 181 is what I have left. So this is my remainder. So remainder goes under the division sign, and I'm going to dip down to 7 squared, which is 49. Okay, so I didn't write that down. That's 181 divided by 49. So let's do that. 181 divided by 49, that equals 3 and some change. I'm going to use the 3. 49 times 3 equals 147. And then I'm going to take 181 and subtract the 147 from that to get the remainder of 34. So I'll just write down what I just did. So again, 49 goes into 181 3 times. And when I take 49 times 3, I got 147. Subtracting those 2, I got a remainder of 34. Okay, so I'm just circling those. All right, so I'm going to take the remainder. The remainder is 34. And I'm going to divide it by 7 to the 1st, which is 7. 7 goes into 34 4 times. So 7 times 4 is 28. I got a remainder of 6. Okay, so 6 is going to be divided by 7 to the 0, which is 1. 1 goes into 6 times, and then we don't have remainder left. Okay, so my answer, make sure we include everybody. My answer is 21346 base 7. Okay, so don't forget when you're converting to their system, you have to divide. The process is longer than multiplying, but just don't forget to do the base with your answer. So you need that subscript there. Okay, thanks for watching. I think we are finished. Yes, we are finished with Unit 1's material. There is extra credit that you can do, so you can watch videos and complete that if you want to. If you don't, that's fine as well. So thanks for watching, and go ahead and do your homework on this section.